Explanation of key terms in the Theory of Entropicity, ToE. The theory of entropicity begins with a simple but powerful idea. Entropy is not just a statistic or a measure of disorder. It is a real physical field that fills the entire universe. Everything we experience, space, time, matter, energy, and motion, comes from the behavior of this entropic field. In this exposition, we provide the core terms and ideas in the theory, explained in plain language. 1. The entropic field. The entropic field is the most basic ingredient of reality. It assigns an entropy value to every point in existence. This value changes smoothly from place to place and evolves over time. According to the theory, the universe is nothing more than the shape and evolution of this field. 2. Entropic configuration. An entropic configuration is simply the pattern of entropy values across the field at a given moment. If the pattern changes, the physical state of the universe changes. There are no particles or forces at the fundamental level, only configurations of the entropic field. 3. Distinguishability. Distinguishability means the ability to tell two physical states apart. In ToE, two states are different only if their entropic configurations are different. The theory requires a way to measure how different two configurations are. 4. Relative entropy. Relative entropy, also known as the Kullback-Leibler divergence, is the only measure that satisfies the rules needed for distinguishability. It is always zero when two states are identical, always positive when they are different, and it behaves consistently under smooth changes of the field. In ToE, relative entropy is the fundamental measure of separation between physical states. 5. Minimal curvature. Even though the entropic field is continuous, physical states cannot be infinitely close together. There must be a minimum amount of separation for a difference to be physically meaningful. When the theory analyzes the simplest possible case, the smallest stable separation turns out to be the natural logarithm of 2. This value is the smallest curvature that can separate one state from another. 6. The Obidi Curvature Invariant. The minimal separation between distinguishable states, which equals the natural logarithm of 2, is called the Obidi Curvature Invariant. It is a universal constant in the theory. It represents the smallest possible entropic difference that reality can recognize. 7. The no-rush principle. Because the entropic field evolves smoothly and cannot jump across the minimal curvature instantly, no physical process can happen in zero time. Every change requires a finite amount of time to unfold. This is called the no-rush principle. It means that reality cannot skip steps or teleport between states. 8. Emergence of space-space is not fundamental. It emerges from the structure of the entropic field. Regions where the field bends or curves correspond to what we experience as spatial geometry. 9. Emergence of time. Time is the ordering of changes in the entropic field. As the field evolves, its configurations form a sequence. This sequence is what we perceive as the flow of time. The arrow of time comes from the fact that entropy evolves irreversibly. 10. Emergence of matter. Matter is a stable pattern in the entropic field. When the field forms a configuration that resists change, we experience that configuration as a particle or a material object. Matter is not a separate substance. It is a stable entropic shape. 11. Emergence of energy. Energy measures how difficult it is to change a configuration of the entropic field. High energy states are those that strongly resist reconfiguration. Low energy states are easier to change. 12. The entropic manifold. The entropic manifold is the mathematical space on which the entropic field is defined. It is the true foundation of physical reality. Everything we observe, motion, causality, geometry, and interaction, comes from the structure of this manifold and the behavior of the entropic field on it. 13. The core message of the theory. The theory of entropicity proposes that entropy is not a byproduct of the universe. Instead, the universe is a byproduct of entropy. From a single entropic field, all the familiar features of physics emerge naturally.